Good morning, everybody, and happy Wednesday. Let's get right into it. So the last brain structure I had with the one with the chainsaw cutting through the egg, hope you like that. I didn't really use the chainsaw to cut the egg, in case you wanted to know. But yeah, using that as like a real basic model of the Earth's main three layers. Well, the yellow, or the yolk, that's going to be the core of the Earth. And then the white part of the egg is going to be the mantle. That's the layer of magma, and which is just molten rock. And then the thin egg shell, that's the crust. So the part we live on is really not very thick in the big scheme of things. And in some places, it's actually just a few miles thick, like Yellowstone. I mean, if you've been to Yellowstone, you're standing on top of a huge volcano, and so tons of responses on that. All right, so let's get right into talking about the mapping activity real quick. All right, so thinking of that eggshell, so that's kind of what our Earth's crust looks like. All of these plates are just kind of like a bunch of puzzle pieces. So once again, here's North America. So here we are. Think about California and Alaska. The biggest earthquake ever recorded was in Chile. And so, yeah, this whole western side of North and South America, well, that's a plate boundary. And these things slowly move, just inches a year. But I think like the North American plate is slowly moving this way. Pacific plate's kind of rotating that way. So, like here in California, they get a lot of earthquakes because those two plates are just sliding past each other. So once again, if this one's sliding this way and that one's sliding that way, and if it's just inches a year, well, still, that then over time is going to cause some major shifts or earthquakes. The plates haven't always been where they are right now. So here's what we look like today. Well, scientists think that 100 million years ago, maybe it looked more like that. If you remember, like Pangea, when they were all one supercontinent. So evidence shows they've certainly changed over time to get us into where we are now. Here was a cool one. It kind of looks fuzzy now, darn it. But yeah, here was the one Maddie had in her presentation I really liked. And so once again, it kind of shows that ring of fire. So yeah, here's North America again. So Alaska, California, and you can see the greener it is, the more earthquakes or the more intensive earthquakes they have. Over here's Japan. They have a bunch there. So that was a cool picture there. And going to your mapping activity, well, you saw it kind of ended up looking similar to this, and that's how scientists tell where the plates are, is by just plotting earthquakes and volcanoes over time. Then you start to see patterns, and this is kind of what yours started to look like, and that is how they get us to where we now have maps like this showing the plates. Now, it's not that all earthquakes or volcanoes occur on those, but a vast majority. Think about like Hawaii. Hawaii is just a weak spot in the middle of the Pacific plate. So the Hawaiian Islands, those are all just volcanoes. And so not all occur on these boundaries, but by far the majority. Here's your speed lecture on plate tectonics and how that mapping activity related. So today I just keep working on that M&M lab for radioactivity. I've gotten a ton of people in. I was really impressed how many people got that done. And yeah, people are saying it takes about 20-30 minutes, so it's not that bad. And then once again, if you don't have M&Ms or Skittles or some type of Easter candy that has those labels, coins will work fine. And then yeah, let's try to do a Kahoot Thursday at 11 o'clock. So tomorrow, 11 a.m., then let's give that a whirl. And we will see you tomorrow. Those radioactivity lab or the M&M lab, get that to me by Friday. All right, see you tomorrow.